All right, this is just a short tutorial on what we call prochirality. So I'd ask you, how many chiral centers are in ethyl benzene? None, right? There are no chiral centers. That carbon's got 2 protons, and methyl can't be chiral. The rest of the carbons are sp2 hybridized, they can't be chiral. But how many prochiral carbons are there? And you should be able to take from clues the fact that I've drawn a wedge and a dash on those 2 protons. There's in fact 1 prochiral carbon. And you get this if you've seen the tutorials on chemical equivalency on the NMR section. I've talked about the chemical test where you replace 1H with X, and you see what the relationship is. Well, if you have a CH2, pretty much any CH2 except in a very symmetrical molecule, right? If we replace 1, so again HA and HB, let's replace HA. I'm gonna draw this as phenyl, so it will be phenyl H. Right? So the two structures you get, if we replace HA, we get the enantiomer of what we get if we replace HB. And so we would actually say that this carbon is a prochiral carbon, meaning that if you make a change, if you substitute one of the protons for something else, you'll get a chiral center there. And this, you might think, is not terribly important, except as you've seen in our test for chemical equivalency in proton NMR, it is important. So right now, HA and HB are magnetically equivalent. They give the same proton NMR signal because they're enantiotopic. But you might imagine, let's say that there's an enzyme made of chiral amino acids that would come in and take one of these H's and replace it with an OH. There is in fact such an enzyme. That enzyme will have preference and be selective to only take HA or only take HB. And so this can get very important when you get to biochemical reaction mechanisms. So anyway, you should be able to identify prochiral carbons. They're typically going to be CH2s or carbons with 2 identical groups and 2 different groups, so that if you replace one of the identical groups with something else, you get 4 different groups in a chiral carbon.